Hello, in this video we will solve inhomogeneous and non-homogeneous second order differential equation using a variation of parameters. So variation of parameters. So what is a variation of parameter? Variation of parameters, which is a way to solve an inhomogeneous or non-homogeneous second order differential equation. Variation of parameters gives you a much broader, grander way of solving more typical forms of second order differential equation. But just like operators, there are limits. So yeah, it's just another method. So how do we solve it? So it's a little bit of review. How do you solve a second order ordinary differential equation? You put it in this form, and you have to make sure that this has an invisible coefficient 1. If it doesn't, you have to get rid of it, right? And the right side does not. Okay, so step 1, to solve the homogeneous complementary equation, you put it in this form. This has a coefficient of 1, and then the right side is 0. And you solve for your r's, right? Uh, yeah, so if you have imaginary, if you have trig, you would do this. If you have just regular two separate r's, it's this. And if you have a repeated root, we'd use this. Then what you would do is find the particular solution using variation parameters using principal of superposition. We replace the arbitrary constants with functions. So yp equals u1 times y1 plus u2 times y2. And we set it up as so it's going to be y1 of u1 prime plus y2 times u2 prime. Set that to 0, and then the other one would be y1 times u1 prime plus y2 prime times u2 prime equals u2. So you have y equals c1 times y1 plus c2 y2. c1 and c2 are not constant but functions. Okay, step 3, you're going to solve for u1 and u2 by applying the Wronskian determinant such that yp equals negative y1 of the integral of y2 g2 all over that's the value w, or also known as the Wronskian determinant. Uh, yeah, so you get your yp, and then so this is how you find your yp, and this is how you find your y1 prime, and then this is how you find your u2 prime. It all makes into, and then step 4, we put it in the general solution. So your general solution is y of h plus yp. Okay, so this all makes sense. We actually do one. So let's do an example. So example 1 says find the general solution to ty double prime minus t1 plus 1 y prime plus y equals t squared. Given that y1 equals e subscript 2 and y of 2 equals t plus 1, form a fundamental set of solutions to the homogeneous differential equation. So okay, so let's do this one. So we got to find the solution. So step 1, we're going to put it in the form of this. Okay, so that's the first step. Um, what do we have? We do not have it in this form. You see this extra t? you got to put it in. We have to have if we have to get rid of that t or make it into a one. So what you're going to do is divide everything by t. So excuse me. So this is what we have. We have t y prime minus t plus 1 y prime plus y equals to t squared. And then what I'm going to do next is get rid of the t by dividing both sides by t. Okay. Now I have y double prime minus t plus 1 y prime and then you have 1 over t y equals to, and then t squared over t is just t. So this t is your g of t. Okay, now find the Wronskian determinant, step 2. So yeah, the Wronskian determinant is going to be the determinant of y1, and then this is y1 prime, and then this is y2, and then this is y2 prime. Okay, so what is our y and our y1? So our y, it was given y1 is et and y2 is t plus 1. Okay, so y1 prime, that's easy. What's the derivative et? It's et. Y2 prime, what's the derivative t plus 1? Just 1. So now you get et, and then y1 prime is et, and then this is t plus 1, and then the derivative t plus 1 is 1. Okay, now this is a 2 by 2 matrix, so it's easy to find the determinant because it's a 2 by 2. So basically you just multiply this minus and then multiply this. So that gives you et, right? 1 times et is et, and then this is going to be minus, I guess we should FOIL this out a bit. So this is going to be t et plus et. And then FOIL out this minus, so it's going to be negative t et minus et. And then you have this extra et. Now, what do you see that cancels the et's? So now you're left with negative t et. Okay. Step 3. Find my u1 prime and my u2 prime. So my u1 prime is negative y2 times it by g all over the Wronskian determinant, which we found. And my y2 prime is y1g over the Wronskian determinant. So let's figure this out. So negative y2, so y2 was t plus 1. So it's going to be negative t plus 1 times it by g. My g was t, right? My g of t is t. And then over the Wronskian determinant, which is this. Not too bad, right? We guess we can clean this up. So this is going to be minus, and then this is going to be t squared plus t. And you should FOIL this out. So this minus would be so if you kind of clean this up, you're going to get t plus 1 e to the negative t. And then let's find u2 prime. So my y1 times g over the absolute value of the Wronskian determinant. So my y1 is et. My g, or my g of t, is t. And then the Wronskian determinant is negative t et. And when you put it all together, you should get negative 1. Okay, so we found our u1 prime and my u2 prime. Now we got to find our u1. U1, I don't get confused. So my u1 prime is this, and my u2 prime is that. Okay. Then what I'll do is find my u1, which is the integral of u1 prime. And then let's find our u2, which is the integral of u2 prime. Okay. So my u prime is t plus 1 times e to the negative t of dt. So this is my u prime now. We'll do that later. Let's just set up u2. So u2 is the integration of u2 prime, which is negative 1 dt. So this one's easy to do. What's the integration of negative 1 dt? Yes, you said it. It's negative t. Let me box it. Now, what about this one's a little bit more different? Should we use u substitution? I don't think it will work. No, it would not work. Since we're multiplying two things, we're going to do integration by parts. Or ELAT, or LIATE, the same thing. Let's see. We don't have an I, we don't have a log. We do have some algebra, right? We have the t plus 1, so I think our u is going to be t plus 1. My du is, the derivative of t plus 1 is 1 dt. And then the leftover is your dv, so my dv is, the leftover is e to the negative t. And then to find your v, you have to take the integral of this, so it's going to be v equals the integral of e to the negative t dt. And what's the integral of e to the negative t? You do have to do a little bit of u substitution, and you get negative e to the negative t. Okay, so now how do you take integration by parts? You do uv minus the integral of v du. So my u is t plus 1, and then my v is negative e to the negative t minus the integral of v du, so that's e to the negative t dt. And you clean this up. Let's put this first. So let's do negative e to the negative t times t plus 1. And then over here you have a minus and a minus, that's plus integration of e to the negative t dt. And we know that the integration of e to the negative t is negative e to the negative t. and then this plus now becomes a minus. So now we get, when you FOIL it out, clean it up a bit, we're going to get negative t e to the negative t minus e to the negative t minus e to the negative t. And when you clean this up more, you get negative t e negative t minus 2 e to the negative t. Okay, so we have our u1. This is my u1. And then my u2 is negative t. What do I do next? So now step 4, we're going to find our general solution. So step 4 is not our general solution. We're going to find yp. So my yp is going to be u1 times y1 plus u2 times y2. And we have everything we need, right? My u1 is negative e to the negative t times t plus 2. Yeah, this one. Or it could be expressed, you could take out an e to the negative t. So this could also be expressed as, you could take out an e to the negative t, and then you have a t plus 2. So it's going to be negative e to the negative t times t plus 2 times my y1, which is et, plus my y2 is negative t times my y2 is t plus 1. So when you put it all together, my yp is negative t squared minus 2t minus 2. Okay, we found our yp. The last step for this is to find the general solution. So what is your general solution? It is y equals yh, y ohms plus yp. So we have everything we need. So my yh is c1 et plus e2 of t plus 1. So this whole thing is your yh. Plus my yp is going to be negative t squared minus 2t minus 2. Okay, so this is your general solution. Okay, so it is kind of tedious, but yeah, so let's do another example. Okay, so example 2 says find the general solution to t squared y double prime minus t times t plus 2 y prime plus t plus 2 equals 2t cubed. Given the complementary solution is y equals c1t plus c2t et. So what do we have? So what would you do? So step 1, I would put it in the general form, right? I would put it in this form. So do we have it in this form? No, we don't. We have this, right? what we have to do is get rid of this t squared. So to do so, you're going to divide both sides by t squared. You get y double prime minus t, and this t cancels, so we're just left with negative t plus 2 y prime, and then this t's cancels, so we're just left with t. Or you could just leave it as it is. We can clean that up a bit. So what is my g of t? Wait, I guess we can clean this up. So it's going to be y double prime minus this t's cancel, you're left with 1. So that's t plus 2 y prime. And this is 2t cubed over t squared. That's going to be 2. So it's t1 or 2t. So we know that our g of t is 2 of t. And we know that our y1 is t. And my y2 is, so my y1 is t, it was given, right? And then my y2 is t et. And then my y0 is, my yh is c1t plus c2t et. And the box it because we'll probably use that later. Or actually, let's circle everything. Go ahead and circle these because we'll probably use it. Okay, steps to find your Wronskian determinant. Wronskian is y1, y1 prime, y2, y2 prime. So my y1 was given t, and then the derivative of t is 1. My y2 was given, it was t e t. And then the derivative of t e t is the product rule, right? So it's going to be, when you take the product rule, you're going to get t et plus et. How do you take the determinant of the 2 by 2? It's pretty simple. It's just you cross multiply. So it's t times t et plus et minus bracket. And then 1 times this whole thing is just itself, right? Okay. And what can we do next? I guess we could just kind of fill this out. This is going to be t squared et plus t et minus t et. And I guess if you clean it up, you're going to get what happens. This cancels, right? So now you're just left with the Wronskian determinant is t squared t. Okay. Step 3, we're going to find our u1 prime and my u2 prime. So my u1 prime is negative y2 times it by g of the absolute value of the Wronskian determinant, and my U2 prime is Y1G of the Wronskian determinant, and my let's fix this. So what is my U1 prime? So it's going to be U1 prime is minus, and then my Y2 is T ET times it by my G that was given, that was 2T, right? At the very end, 2T. And what else? All over the Wronskian determinant, which was given as T squared ET, okay? If you clean this up, eventually everything will cancel, so you're just left with -2. So your y1 prime is -2. Now let's finish up our u2 prime. So my y1 is t, my g is 2t, all over the Wronskian determinant, which is t squared et. And when you clean that up, let's see, when some of the t's cancels, or the t's cancel, so you're just left with 2 over et, but you can also rewrite that as 2e to the -t, right? This is the same thing as this. So my u2 prime is that. Box it. Now let's find our u1 and our u2 by taking the integral of those answers. So my u1 is the integral of u1 prime of dt, and my u2 is the integral of u2 prime of dt. So this is going to be u1 equals, what my u1 prime was -2 dt, and my u2 is the integral of u2 prime, which was 2e to the -t dt. Okay, let's clean this up. So my u1 is, what's the integral of -2? -2t. This is going to be u2 equals -2e to the -t. Okay, step 4. So now let's find our yp. So our yp is u1 times y1 plus u2 y2. We have everything we need. My u1 is -2t. My y1 is t. Plus my u2 is -2e to the -t. Times it by my y2 is t e t. So my yp is going to be -2t squared minus 2t. Step 5, find the general solution. So my general solution is going to be y equals y of h plus yp. And we have everything we need. So my y1, my yh was c1t plus c2t et plus my yp, which is this, -2 t squared minus 2t. Okay, can we use this as our final answer? Not quite. Do you see something repeat or something similar or something that's the same? Yes, I see that this is very similar to this. So we can omit it since it replicates from the y-h. We ignore anything with a duplicate. So if you have something, a repeat, you can just ignore it. So our final answer was going to be y equals C1t plus C2 TET minus 2t squared. So I just ignored this, and that's my final answer. Okay, let's move on. Let's do example 3. So example 3 says, find the general solution to the inhomogeneous differential equation of y double prime plus y equals tan t. So first step, put it in the general form. Step 1, put it in the general form of this. Y double prime okay, did we have it in that form? Actually it does. It's that except here. What we have is y double prime plus y equals to tan t, right? So we do have it in the form. It's just that we're missing something. We're missing our y prime or this part, right? So you're just going to have to replace it with 0. So it's going to be y double prime plus 0 y prime plus y equals to tan t. Okay. Step 2, kind of solve for your r. So this is r squared plus 1 equals to 0. And when you solve for r, you subtract 1, you get r squared equals -1. And you're going to get r equals 0 plus or minus I, right? When you take the square root of this, you get imaginary. So this 0 is your alpha, and then this I is your beta. So my YH is going to be C1 E of 0t of cosine of t plus C2 E 0t of sine of t. So my Y of H is C1 cosine of t plus C2 sin of t. Okay, so this is your Y1 and this is your Y2. So before we move on, let's figure out what our G of t, let's review what our G of t is, our Y1 and Y2. So my G of t, because we're going to probably use it again, my G of t is, I believe, tan of t. My Y of 1 is cosine of t. And my Y2 is sin of t. Okay, so let me go ahead and box this because we'll probably use it again. Step 3, find the Wronskian determinant. It's going to be absolute value W. I mean, the Wronskian determinant, not the absolute value W, which is the determinant of Y1, Y prime, Y2, Y2 prime. So my Y1 was given cosine of t. And then the Y1 of prime, or the derivative of cosine t, is negative sin of t. My Y2 is sin of t. My Y2 prime, the derivative of sine t, is cosine of t. And then this is easy. This is a very easy fix to find the determinant of 2 by 2. So just cross multiply. So cosine times cosine of t minus cosine of t minus you put a bracket if you like, negative sine of t times positive sine of t. So this is going to be cosine t times cosine t is cosine square t. And over here, two negatives becomes a positive, so that is sine square t. And we know that the cosine squared t plus the sine squared t is going to equal to 1. So the Wronskian determinant is 1. Okay, step 4, you're going to find u1 prime and my u2 prime. So step 4, let's find our u1 prime, which is negative y2 t times g over the Wronskian determinant. So we know we have everything we need. My negative y2 is, well, y2 is sine of t, so the negative of that is negative sine of t. And then my g is tan of t all over 1. And then my y2 prime is y1 times g over the Wronskian determinant. So my y1 is positive cosine of t times it by my g, which is tan of t. And then the Wronskian determinant is 1. Okay, now let's find our u1. So my u1 is the integral of u1 prime. So what is that going to be? U1 prime is this whole thing. Yeah, it's negative sine of t times tan of t dt. What could we do? We have a minus right here, so we could take that out. And then I guess we can like clean it up a bit, like put in terms of sine and cosine. So I'm going to leave sine t alone, but I can rewrite tan of t in terms of sine and cosine. That is the same thing as sine of t over cosine of t. And that's going to give you y1 equals negative, excuse me, sine of t times sine of t is sine squared t over cosine of t of dt. So you can simplify this even more. Sine squared t is one of your Pythagorean identities. That would be simplified as 1 minus cosine squared t all over cosine of t. And then you still have this minus. And I guess you can clean this up a bit, right? So you're dividing each term by cosine of t, so you could break it to two integrals. So it could be expressed as 1 over cosine of t minus cosine squared t over cosine t is cosine. Cosine squared t over cosine t is cosine of t of dt. And we can clean this up. 1 over cosine of t is the same thing as secant of t minus cosine of t of dt. And then what we do is use our integral rule. So the integral of secant t is negative, or actually positive, but then you distribute them. Don't forget you still have this minus. So it's ln of the absolute value of secant t plus tan of t. And then the integral of negative cosine t is negative sine t. And then don't forget you still have this extra minus, so bring that down. So this is your u1, I box it. And then our u2, I didn't do that one. but the u2 is pretty simple. u2 is the integral of u2 prime of dt. That's u2, and then u2 prime is cosine of t times tan t dt. That's going to be u2 equals the integral of cosine of t, and then the integral, we can rewrite tan of t as sine of t over cosine of t dt. And then what happens is the cosine of t cancels, so you're left with u2 equals the integral of sin of t dt. So my u2 is negative cosine of t. Okay. So we need this, and we're going to need my u1. So step 5, find my yp. So my yp is u1 y1 plus u2 y2. So my u1 y1, my u1 is this whole thing times it by my y1, which is cosine of t, and then my u2 is negative cosine of t, and then my y2 is sine of t. So we have everything we need. So it's going to be negative ln of absolute value of secant of t plus tan of t plus sine of t. So that whole thing is my u1, and then times it by my y1, which is cosine of t, plus my u2 is negative cosine of t times it by my y2, which is sine of t. So my yp, we clean it up, is going to be negative cosine of t ln of secant of t plus tan of t. This is my yp. Okay, step 6, put it in the general solution. So the general solution is y equals yh plus yp. So my y is going to be c1 cosine of t plus c2 sine of t minus cosine of t ln of the absolute value of secant of t plus tan of t. Okay, so this is your final answer, general solution. Okay. Okay, let's do one more example, and I think this will be our last one for this lecture. Okay, example 4 says find the general solution to the inhomogeneous differential equation. I lied. I think we're gonna have a total of 5 examples, so there's 2 more examples. Find the general solution to the inhomogeneous differential equation. We have y double prime plus 3y prime plus 2y equals sin of et. So step 1, put it in the general form. Which I think we're good because it is in the general form itself, right? There's an invisible one here, so we're good. So yeah, we are good. It is in the general form, so my g of t is sin of et. So step 2, find yh. So it's just going to be r squared plus 3r plus 2 equals to 0, and then we can factor this out. it's going to be r, where two numbers multiply 2, one added gives you 3, plus 2, plus 1, and you get r equals -1, -2. And these are two distinct, right? So my y of h is c1 e to the negative t plus c2 e to the negative 2t. And then my g of t is sine of et. And then my y1 is e to the negative t, and my y2 is e to the negative 2t. Okay, go ahead and box it because we'll probably use it again. Okay, step 3, find the Wronskian determinant. So my it's y1, which is e to the negative t, and then my y1 prime, which is negative e to the negative t. My y2 is e to the negative 2t, and my y2 prime is negative 2e to the negative 2t. Okay, go ahead and cross multiply. So this is going to be e to the negative t times negative 2e to the negative 2t minus e to the negative 2t times it by negative e to the negative t. And when you put it all together, you get negative 2e to the negative 3t plus e to the negative 3t. So my Wronskian determinant is negative e to the negative 3t. Okay, step 4, find your u1 prime. So my u1 prime is negative y2 times g of the Wronskian determinant. And that is going to be negative, and then my y1, my y2 is e to the negative 2t times it by my g, which is sin of et, all over my Wronskian determinant, which is negative e to the negative 3t. Okay. And then my y2 prime is y1 times g over the Wronskian determinant. My y1 is e to the negative t, and then my g is sin of et, all over negative e to the negative 3t. So my u2 prime is negative e 2t times sin of et. Okay, now what we have to do is find my u1, which is the integral of u1 prime of dt. So that is going to be the integral of et sin of et dt. And then how do you find the integral of this? You could just simply use substitution. I'm going to say, instead of u, I'm going to say let x equals et. And then my dx is going to be et dt. And then if you want to solve for dt, right, dt is going to be dy over et. So this is going to be simplified as u1, the integral of et, and then it's going to be sin, and then we can replace e of t with x, and then you can replace dt with dy over et. And as you can see, the et's cancels, so your u1 is going to be the integral of sine of x dx. So my u1 is negative cos, because the integral of cosine x is negative cosine, and then our x is et. Okay, now let's find our u2. So my u2 is the integral of u2 prime dt. So that's going to be u2 prime is negative e of 2t of sine of et dt. And we can take the integral by using u sub. So my x is going to be et. And then my dx is et dt. So my dt is dx over et. So my u2 is negative the integral of e to t of sine of x. And then you can replace dt with dx over et. So my u2 is negative the integral of et of sine of x dx. And how do we take the integral of this? Yes, we got to do integration by parts, right? So yes, let's do that. So let's set a, we can use a different, you can use any letter you like, but I'm going to say, let's say a equals x, and then my dA is dx, and then my dv is sin of x dx, and then my v is negative cosine of x. So the integration by parts is going to be minus av minus the integral of v dA. So a is x, v is negative cosine of x, minus the integral of negative cosine of x dx. And you get, here you have an extra minus, so that is going to be x cosine of x minus sine of x. Oh, wait, so this becomes a positive, so now it's going to, and then you have an extra minus, so that's going to be negative sine of x dx. So my u2 is going to be et cosine of et minus sine of et. Okay, let me box it. Okay, now step 5. We have our u1 and our u2. Step 5, find your yp. So my yp is u1 times y1 plus u2 y2. Okay, so it's going to be, so my u1 is negative cosine of et. My y1 is et. Plus my u2 is et cosine of et minus the sin of et times y2, which is e to the 2t. And when you clean that up, I'm just going to do the work. When you clean this up, you should get negative e to the negative 2t of sine of et. Step 6, find the general solution. So we have everything we need. Our general solution is YH plus YP. So that is going to be C1 e to the negative t plus C2 e to the negative 2t, and then plus a negative e to the negative 2t of sin of et. Okay, let's do one last example, and this time let's say pretend one of our roots were repeated roots. So let's do a last example. And what happens if we have a repeated root? So example 5 says, find the general solution to the inhomogeneous differential equation y double prime minus 2y plus y equals et over t squared plus 1. So step 1, put it in the general form. And I think it is in its general form because this is a coefficient of 1. So we don't have to divide anything by anything. Okay. Step 2, find your y of yh. So that it's going to be r squared minus 2r plus 1 equals to 0. And then if you factor this out, this is going to be r, where two numbers multiply 1 and add gives you negative 2, negative 1, negative 1. As you can see, my r value is positive 1 and positive 1. And as you can see, you have a repeated root. So my y of h is c1 et plus c2 t et. Okay, then let's see, our g of t, so let me write this down. Our g of t is basically this. So my g of t is et over t squared plus 1. And then my y1 was given it's et. And then my y2 is t et. Go ahead and box it because we'll probably use it. Okay. The Wronskian determinant is, so my y1 is et. My derivative is et. My y2 is t et. And then the derivative of TET is product rule, so you'll get TET plus ET. And then to take the determinant of 2 by 2, you just multiply it out. So this is going to be ET times TET plus ET minus multiplication of that. I'll use a bracket, so it's going to be ET times TET. And when you clean this up, you're going to get TE 2t plus e 2t minus t e 2t. When you clean that up, your Wronskian determinant is e 2t. Okay, step 4, find your u1 prime and your u2. So my u1 prime is negative y2 times g of the Wronskian determinant. And my u2 prime is y1 times g over the Wronskian determinant. Okay. So it's going to be u1 prime is negative t e t, and my g is e t over t squared plus 1 over my Wronskian determinant, which was e to the 2t. So how would I do this? So when you know how to do, you could do this. Like you, on the top, you have a complex fraction. Your LCD is t squared plus one. So when you put it all together and you simplify this complex fraction, you should get 1 over t squared plus 1. So I'm not going to do the work because you should know how to do this from algebra. This whole thing is your numerator. This whole thing is your denominator. You have a complex fraction. Simplify the numerator, find the LCD, right? Or no, or multiplying fraction, so you don't need the LCD. Just multiply across, and then uh, divided by e to the 2t, and you should get this. And what did I say? My u2 was going to be, my u2 prime is uh, e t times e t over t squared plus 1 over e to the 2t. So if you do this again, this is e to the 2t over t squared plus 1 times it by, this simplifies, you can just multiply this by 1 over e to the 2t, and you get, oh, I made a mistake. My u1 prime is not, when you simplify this, you should get negative t over t squared plus 1. I made a mistake. And then over here, when you simplify it, you should get 1 over t squared plus 1. Okay, so this is my u2 prime, and this is my u1 prime. So my u1 is, now let's find our u1. So it's the integral of u1 prime. So that's the integral of negative t over t squared plus 1 dt. And you could just get away with this using u substitution. So you can say, I'm not going to use u because you have a u here, so that's why I use x's. Or you could use it anywhere you like. So I'm going to use x as t squared plus 1, and then my dt is dx with 2t. Basically, I just take, so it's like x prime, right? Dx is 2t, and then dt. And then what you did was I solved for dt by getting rid of this 2t. So that's how I just did one extra step. And so now my u1 is the integral of negative t over x times it by dx over 2t. And then simplify this. This is the n equals to, this is a negative 1/2, so put that out. And then the integral of 1 over x dx. So my u1 is negative 1/2, and then the integral of 1 over x is ln of the absolute value of x, which is t squared plus 1. Okay, so my u2 is this. Now let's finish our u2. So my u2 is the integral of 1 over t squared plus 1 dt. And this is, no, you don't have, I wouldn't use the substitution. It's one of your special trig rules, your special integral inverse rule. So this is going to be 1 over AB times tan inverse of AX over B. So my U2 is tan inverse of T. So yeah, we have our U2 and our Y1. U1. Now step 5, is find your YP equation. So my YP is U1 Y1 plus U2 Y2. So my YP is going to be negative 1/2 ln of the absolute value of t squared plus 1 times by my y1, which is et, plus my tan inverse of t times it by my y2, which is t et. And then my step 6 is find the general solution. And the general solution is y equals yh plus yp. So it's going to be y equals c1 et plus c2 t et minus 1/2 et ln of absolute value of t squared plus 1 plus t e t tan inverse of t. Okay, so this is your final solution. Okay, so that wraps up for this lesson. We can stop here.